Now we are going to discuss properties of a parabola. First property is that is P1. Let P of T1, that is parametric equation of parabola, and Q of T2 be another point in the parametric equation form, be 2 points on a parabola. Y square is equal to 4ax, and if PQ is a focal chord, then T1 T2 is equal to minus 1. Now we have to prove this. If this property holds, then we can use this concept. If P and Q are 2 points in parametric equation form and PQ is a focal chord, then T1 T2 product will be minus 1. So the proof is if PQ is a focal chord, then PQ is latus rectum. Then 1 and P will have coordinate a, 2a, but P has parametric form, that is a T1 square, 2a T1 as coordinate. Therefore, a T1 square is equal to a implies T1 square is equal to 1. That is T1 is equal to plus minus 1 and 2a T1 is equal to 2a implies T1 is equal to 1. So from these two concepts we will have T1 is equal to 1. Then this result will hold true. Similarly, for point Q, we'll have the coordinate a, minus 2a and parametric form, that is Q is a T2 square, 2a T2 give a T2 square is equal to a, that implies T2 square is equal to 1, that implies T2 is equal to plus minus 1 and 2a T2 is equal to minus 2a, that implies T2 is equal to minus 1. So from both these two concepts we get T2 is equal to minus 1. So if we take the product T1 into T2, T1 is 1, T2 is minus 1, we get minus 1. That is if PQ is a focal chord with given parametric equations as the coordinate, then T1 into T2 is equal to minus 1. Suppose PQ is not the latus rectum. Therefore, 81 square is not equal to A and 82 square is also not equal to A. But as PQ is a line, then S is the focus, then slope of SP, that is P will be at the same distance from the S, then its slope will be same as SQ. Therefore, slope of PQ will be equal to therefore slope of SP will be equal to slope of SQ. So by the slope formula y2 minus y1, that is 2at1 minus 0 over at1 square minus a, and 2a t2 minus 0 over at2 square minus a. So we will solve this. We will get 2at1 over a is common, t1 square minus 1 in the numerator, and 2at2 over a is common out, t2 square minus 1. So cancelling the same figure, we will get t1 over t1 square minus 1, t2 over t2 square minus 1. Then cross multiply and we will get t1 into t2 square minus t1, t2 into t1 square minus t2. So from taking the same term on the both sides, that is t1 t2 square minus t2 t1 square, and here t1 comes out become positive minus t2. From these two terms we will give t1 t2 common, and in the bracket we will get t2 minus t1 is equal to t1 minus t2. So that gives t1 into t2, t2 minus t1 is equal to minus t2 minus t1. So on cancelling the same factor, we will get t1 into t2 is equal to minus 1. That is, if PQ is not a focal chord, then this result is also true for 2 points lying on the parabola and making it chord. So this is a property of parabola. Now the property number 2 is, let S be the focus of the parabola. Y square is equal to 4ax, where a is greater than 0, and PQ be a focal chord, then 1 over SP plus 1 over SQ is equal to 1 over A. Now we will prove it by taking parametric equation. Let P of T1 and Q of T2 be the endpoints of a focal chord. The coordinate of focus are S of A, 0 and coordinate of P are at1 square, 2at1, and coordinate of Q are at2 square, 2at2. Now we will find out SP and SQ. So we will take SP square. So distance between S and P, by using distance formula, we get at1 square minus A whole square plus 2at1 minus a whole square, as under root is cancelled out by this square. So we get, of opening this, we will get, that is, here it should be 0 because coordinate of focus is a comma 0. So 2at1 minus 0. So opening square and under root is cancelled out and we get 81 square minus a whole square, that is a square 81 square whole square plus b square minus 2ab plus 281 whole square is 4a square t1 square. So as a whole we get a square t1 raised to power 4 plus a square minus 2a square t1 square plus 4a square t1 square is 2a square t1 square. So we'll again get the formula of a square t1 square plus a whole square. That is a square plus b square. That is a t1 square, not a square, it is a t1 square. Because on squaring we will get this, on squaring of a we will get this, and 2ab we will get this. So this is a plus b whole square. Therefore, as p distances, squaring will be cancelled out and it becomes a is common, t1 square plus 1. So in the same manner, when we will solve SQ, if you want to solve, you can solve it, and there is symmetry, we will get SQ is equal to A T2 square. Therefore, SQ is A T2 square plus 1. Because the points are same, but there is a little bit difference in the points notation, that is T1 in place of T2. So we get the same distance. Therefore, according to question, 1 over SP plus 1 over SQ is equal to 1 over A T1 square plus 1 plus 1 over A T2 square plus 1. So we get 1 over A is common out, and in the bracket by taking LCM we will get T1 square plus 1 T2 square plus 1 over T1 square plus 1 into T2 square plus 1. So as we know, T1 T2 is minus 1, but T1 square T2 square will be 1. Therefore, we can replace 1 by T1 square T2 square here. So T1 square plus T2 square plus T1 square T2 square plus 1 over T1 square plus 1 T2 square plus 1. So if we see from here, we can take the common out some terms. We can take T1 square from both terms, and the bracket we get 1 plus T2 square. And remaining these two terms will be taken in one bracket by taking one as common factor. And we get 1 plus T2 square over T1 square plus 1 and T2 square plus 1. So we get 1 over A in the bracket T1 square plus 1 and 1 plus T2 square over same factor in the denominator T1 square plus 1 T2 square plus 1. These will be cancelled out and we get 1 over A. That is our required result. That is, if SP is a distance between lattice spectrum or focal chord 1 point and the focus, and SQ is the distance between focus and other end of latest vector or focal chord, then reciprocal over the resistance, and then by taking sum it is equal to 1 over reciprocal of focus point, that is 1 over SP plus 1 over SQ is equal to 1 over A if A is greater than 0. Now the third property is, that is P3. Let P be any point on a parabola and S be the focus of the parabola. Y square is equal to 4AX. Let PQ be a line parallel to the axis of the parabola let the bisector of the angle SPQ intersect axis of parabola in point G, then SP is equivalent to or congruent to SG, that is same length and same direction, equal. They are congruent. Now we have to prove if PQ is a parallel line to the axis of parabola. So first of all, we will draw the diagram. This is x-axis and this is y-axis, and we have the parabola y square is equal to 4ax, and we have a line parallel to axis. Axis of parabola is this, so this is a line which is parallel to axis, and we have to bisect. This is the focus SPQ. So bisector of SPQ meets the axis at the point G. So G cuts the axis at the point. This is the bisector. PG is the bisector. So in this figure, PG is the bisector of measure of angle SPQ. As it is a bisector, therefore angle 1 is equal to angle 2. And also we have PQ is parallel to SG and SG is a transversal line between PQ and SG, that is PG is a transversal line. Then we can say this like figure. This is the alternate interior angle. Then these two angles, that is angle 2 and angle 3, both will be equal as PQ is parallel to SG and PG is a transversal line. That is PG is the transversal. Therefore, angle 2 is equal to angle 3. But we have angle 1 is equal to angle 2. Therefore, angle 1 is equal to angle 3. That is angle SPG is equal to SGP. And we know that opposite side of equal angle is equal. So opposite side to SPG is SG and opposite side to SGP is SP. Therefore, triangle SPG is an isosceles triangle. So, as the two angles and angle formed by this and sides are of equal length, therefore SP is congruent to SG. So this is the third property of parabola. This was all about the conic parabola.